Good day, everyone. Welcome once again to our lecture for this session. So last time we discussed about one-sided limit. So this time we are going to emphasize more of this concept before we go to the next topic for our uh, limit of a function part 5. Okay, so last time I have given you this number for your practice to determine whether this given function exists or does not exist. So we're able to do it. Okay, so if you haven't done it yet, then listen carefully of our lecture today so that you will be able to understand more. Okay, so I will emphasize a little bit what is this one-sided limit, and we have two-sided limit. Okay, so we have here another example. In this graph, we are asked to determine whether the limit exists or does not exist. So I will explain this later on after we review the basic concept about one-sided limits. Alright, so in some cases, a function may approach either of two different limits depending on whether the variable approaches its limit through values larger or smaller than that limit. So in such a case, the limit is not defined or does not exist, but the right hand and left hand limits exist. Okay, for example, from this picture, so we have um, as x approaches to c, so what will be the limit of the function? So as discussed last time, the limit of the function as x approaches to c is equal to, so depende where the value is coming from. Okay, so let's see whether the limit of the function as x approaches to c does exist or doesn't exist. Okay, so to find out, we have to uh, find the limit of the function of x as x approaches c, that is from the left. Okay, so the symbol here or the sign here, which is negative, it means that uh, x value is coming from the left. So if we consider this graph here, okay, so coming from the left towards c, okay, so our x is coming from the left towards c. Okay, so what is the limit of our function? So from the graph, we can see that the limit of the function as x approaches to c from the left, so this is equal to this value, which is 3. No, we have already discussed this last time. Alright, now to find the limit of the function of x as x approaches to c, but this time this is coming from the right. So we have c, then we have positive sign at the head of the c, so it means that it's coming from the right towards c. Okay, and then we are going to consider this graph, this one here. So what is the limit? Okay, so for this graph, the limit is equal to 5. Alright, so both of the limits exist, but if you see them, the left hand, you see here, this is what we call left hand limit, so we call it LHL. Okay, so the left hand limit is equal to 3, and the right hand limit is equal to 5. Okay, now comparing the two limits. Okay, so the two limits are not equal, so we can say that limit or left hand limit is not equal to the right hand limit. So what does it mean? Okay, so since the left hand limit is not equal to right hand limit, or does not match the two limits, so therefore this limit of a function as x approaches to c does not exist. Okay, so we can see does not exist, or DNA. Alright, so this is what we had discussed last time. Okay, so I hope you recall this one, and I hope this time, if you were not able to understand before, I hope that this time you already understand or understood. Okay, so here we can say that the limit of function does not exist. The limit of function f of x as x approaches to c does not exist. Alright, now we have the right hand limit. So let's give emphasis now on the right hand limit. So the right hand limit of a function f of x at point A is the limit of the function at A as x approaches A from decreasing value of A. That is, as x approaches A from the right. Alright, so this is given in this expression. Limit of f of x as x approaches to A. The positive here indicates that the values of x are coming from the right towards A. And this is equivalent to L. L means limit. Alright, so for example, if you're asked to evaluate this limit, so evaluate limit of square root of x as x approaches 0. So here we have positive, it means from the right. Okay, so let us note on this that the domain must be greater than or equal to 0. Why? Because if you have a negative number here, this makes the limit of the function undefined. So we cannot find the value of a square root of a negative number. So that's why we have to take note on this, that x must be greater than or equal to 0. Okay? So we have here a table that shows our x and also the value of f of x. When you plug in the value or substitute the value of x to the function, this is our function, square root of x. Okay, so as mentioned, if the values are negative, so we have here u. Just put u here to indicate that the result of the calculation is undefined. So we cannot find the value of the square root of a negative number. Okay, so since our x must be greater than or equal to 0, so we have to consider values from 0 going to the right. Okay, but here, as mentioned in this presentation, x approaches 0, then we have plus at the top of 0, so it means that the values coming from the right, okay, towards 0. Okay, so we have here the values of x, so we go to 0, that is from the right. So we have 4, 3, 2, 1, 0. So if you substitute these values to f of x and you draw or plot the points, okay, so plotting the points, then you will obtain, oh, by the way, what is the function now? What is the limit of the function as x approaches to 0 from the right? So that is our problem class now to find out. Okay, so para we can get the idea, let us draw or graph the function first. Okay, so the function here, as you plot the points, so when x equal to 2, okay, so you have f of x, it's somewhere here. Okay, so 1.4, or if you start with 0 at x equal to 0, so f of x equal to 1. Okay. Sorry, when x equal to 0, we have f of x equal to, so here, when x equal to 0, so this should be 0 here. Okay, sorry, this should be 0. Okay, so when x equal to 0, so square root of 0, that is 0, so f of x is also 0, so it's here. When x equal to 1, f of x is 1. Okay, so when x equal to 1, so f of x is equal to 1. It's here. And when x equal to 2, so f of x equal to 1.4 something, no? So it's somewhere here. When x equal to 3, okay, so when x equal to 3 here, so we have this 1.73. Okay, it's very close to 2. And when x equal to 4, so you have f of x equal to 2. So this is our f of x, the vertical line. So y is equal to f of x. Okay, so from this graph, you see from the right, you take values, say for example from 10. Here we just limit our values to 4. Then you go to the left, sorry, go to the 0. We're starting from the right towards 0 because as x approaches to 0, plus here from the right, so we're coming from the right towards 0. Okay, so look at the graph. Okay, so from this point, you go, your values of x is varying from 10 down to 9, 8, 7, 6, 5, 4, 3, 2, 1 until we reach 0. Okay, so it means that the values of x approaching, from the right towards 0. Okay, so in short, this indicates that all values from the right of 0 going to x equal to 0. Okay, so now with this we find that the value of the limit, or the limit of the function f of x, which is square root of x as x approaches to 0 from the right, is equal to 0. Okay, so this is our answer. Alright, now the left hand limit. So let us review for the left hand limit. So the left hand limit of a function f of x at point A is the limit of the function at A as x approaches A from increasing value of A. That is, as x approaches A from the left. Okay, so the negative sign here indicates that the values increasing, no, from the left going towards A. All right. Okay, for example, if you have if you're asked here whether the function exists or not. Okay, so we are given that the limit of f of x as x approaches to -1 from the left. Okay, then we are given the condition here that if the interval is, we have here x less than or equal to -1. So what does it mean? So for example, this is our number line system. This is our 0. Okay, then we have here -1. We have here -2, -3, then we have here 1, 2, 3. Okay, so we have here this is the boundary. Okay, so values x, so it means values that belongs to this interval. Okay, so this is where x less than or equal to 1, and the other side here, so this is where our x that is greater than -1. So it's shown in this illustration class that here for the interval that is x less than or equal to -1, so we have here the value of the function is equal to 6. Okay, so it means that the limit of f of x as x approaches to -1 from the left, so that is equal to 6. Okay, for example here, say when x equal to, by the way, the spacing here, we have here 1. Okay, this is -1. Okay, and then this is -2, and then you have -2.5. Okay, this is at this point -2.5, and so on and so forth. So when x equal to -1, all right, so we have here, we just extend the line vertically. All right, so we have equal to 6. So at this point, this is 4, 5, so this is 6. Okay, now if the values of x belongs to this interval, x less than or equal to -1, it means to the left of this. So starting from here, going to the left, so all these values, negative values, so you have the limit of the functions from left, from left to right, or you're graphing or tracing this graph from here going to the right. Okay, coming from the left. All right, so we have here the function is equal to the value, the limit of the function is equal to 6. All right, now for the values for x on this interval, x greater than -1. By the way, class, going back here, so you see here it's a solid, it's a shaded part. It means that x equal to -1 here is included. So this interval here can also be represented as this is -infinity and -1. Okay, so parenthesis here because open parenthesis because infinity is not included. Here we have bracket. Okay, so it indicates that -1 here is included. So shaded, it corresponds to a shaded portion. So this is at x equal to -1 because included. Alright, so shaded. This is shaded. Okay, so that is the limit of function of x as x approaches to -1 from the left. So how about the limit of the function as x approaches to -1 from the right? So it means that we have to consider this graph. Okay, so from the right, okay, so we are tracing this curve from the right towards the value which is -1. Okay, so we have here x greater than -1. So it means for this interval, okay, for this interval we have 3. Sorry, this is -1. Okay, -1. So parenthesis. Then we have positive infinity. Okay, so what does it mean? If that is parenthesis, so it means, class, that so -1 here is not included. So that's why you can see here that this is a hollow. Okay, this is a hollow. So that indicates that this is not included. So for this part of the graph, from right going to left approaches to -1, we see that the limit of the function is equal to, so look at this. This is -1, -2. Okay, so this part here is -2. Okay, So that's why the limit of the function from the right is equal to negative 2. So now both limit exist. From the left going to negative 1, we have positive 6. From the right going to negative 1, we have the limit equal to negative 2. So both limit exist but they are not equal. So therefore, since they are not equal, the limit, right, the limit of the function, the limit of the function of x as x approaches to negative 1, so the limit does not exist. Okay, DNA does not exist. All right. So any question? So you don't have to put equal sign here, class. You don't have to put equal sign because it's not correct. So you just say that the limit of the function of x as x approaches to negative 1 does not exist. Or you may put an arrow so to indicate that it doesn't exist. Okay, so that's the one side limit coming from the right and also coming from the left. Okay, now we have two-sided limits. So the limit exists, so ito yung condition, class. The limit exists if and only if the right hand limit and the left hand limit both exist and are equal. Alright? So the limit of f of x equal to L as x approaches to a from the right must be equal to the limit of the function as x approaches to a from the left, and that is also equal to L. So if the value of L here is equal to the value of L here, meaning both limits are equal, then the limit of the function exists. Otherwise, the limit does not exist. Okay, so this is the thing that I would like to emphasize, class. In our previous lecture, in our part 4. So this is still part of our part 4 lecture. So I'm just elaborating some points here or highlighting some points. Okay, so let us apply, if we can really or if we really understood the lecture for today. So let us see if you can solve this problem. So here we are asked to determine whether the limit of the function as f of x, limit of a function of x as x approaches to 1 exists or does not exist. Okay, so the same thing we have here. This is the value of c where x approaches to, this is positive 1. Okay, so we have to determine the limit of the function as x approaches to 1 from the left. Okay, so from the left, so we have to trace coming from here. This is the left side of this reference, which is 1. Alright, so when you trace the graph from the left towards the value x equal to 1 or very close to 1, so we could say that the limit of the function as x approaches to 1 from the left is equal to 0, right? Because f of x at this point is equal to 0. So we're not after, class, the exact value. We're just concerned on the value where f of x is approaching to as x approaches to 1. Okay, so we say that this is equal to 0. Now, considering the other part of the graph, so we have to consider the limit of function as x approaches to 1 from the right. Okay, so let us trace the graph. So from the right, so we have this graph going in this direction. Okay, then it goes down and then it becomes flat towards 1. Okay, so because approaching positive 1, positive 1. Alright, so plus here again, we're tracing coming from right going to 1. Okay, so this is the limit. Okay, so what is this value? Okay, so the value or the limit here is equal to what? So that is equal to 1. Okay, so you see here the one-sided limits coming from the left and coming from the right both exist, but they are not equal. So therefore, we can say that the limit of the function of x as x approaches to 1 does not exist. Okay, then do not put equal sign here. Huh? You may put an arrow, okay, but do not put anything there except this one or a sign of equal sign. So it's not equal. So we're just saying that the limit of the function as x approaches to 1 does not exist. Okay? And take note that the limit of a function is not equal to the value of the function. Take note on that. For example, if you have, say, f sub 1, meaning the value of the function at x equal to 1. Okay? So the value of the function at x equal to 1 is equal to 1. Alright? So, limit of the function as x approaches to 1 is not equal to the value of the function when x is equal to 1. Alright? Okay, so I hope it's clear. Next, we are given here the same graph as in the previous graph, but this time we have the limit of the function of x as x approaches to 2. Okay, so this is now the value that x approaches. So approaches to 2. So the same thing, we have to find the limit of the function as x approaches to 2 from the left and also from the right, and then compare both limits. Okay, so the limit of the function of x as x approaches to 2 from the left. So we have to trace again this graph. Okay, so we're coming from the left towards 2, so it goes down as the value is closer to 1, and then it's okay. So we cannot find the value here. It jumped here. Okay, so as we continue to move, going to the right, and it approaches to 2. Okay, so it approaches to 2. Now approaching the 2. So as we mentioned, we're not after the exact value, but we are concerned on the value that the x is approaches to. So in this case, it approaches to 2, and what is our f of x at this point? Okay, so this is equal to 1. Alright, so the value of the function, I mean the limit here of the function is equal to 1. So we're not really looking at the exact value, but we're just looking at the value that it approaches to as x approaches to 2. Okay, so at this point, so we have f of x is equal to 1. Alright, now for the graph coming from the left. Okay, so what we did a while ago, so we are just tracing the graph from the left towards this value of x. Okay, so from the left going towards 2, because of this symbol or sign that's negative. Okay, so the other part is when we are tracing the graph from the right. Alright, so from the right we trace the graph going there, so it means that our value of x is decreasing. Okay, so these are the values of x. Okay, so when we move going to the left, so we're coming from the right, the value of x is decreasing. Okay, and then up to here, right? So this is also the limit of the graph from the right going to 2. Okay, so we're tracing from the right towards 2. Okay, so now what is the value of L here? What is the limit? So again, this is 1. So we can say that this is also equal to 1. So you see here that the limit of the function from the left and the limit of the function from the right both exist, and they are equal. No, they are equal to 1. So the values match or matches. So because the left and the right hand limits matched, then we can say that the limit of the function, this expression as x approaches to 2, exists. It exists, and this is equal to 1. Okay, so the value here, whatever is the common value here, that is also the value of our L here, the limit. Okay, so I hope it's clear now. Now again, as I mentioned, the limit of the function is not equal to the value of the function. For example, we are here. We are having here limit of function as x approaches to 2 from left and right, and when we found that they are both equal, so the limit also exists and equal to 1. But now if you are going to solve for the limit of the function as or if you solve for the value of the function when x equal to 2, so what is the value of the function when x equal to 2? So this one. Alright, so that is equal to 2. So you see, the limit of the function as x approaches to 2 is equal to 1, but the value of the function when x equal to 2 is equal to 2. So they are not equal. But perhaps in some cases, but in this case, they are not equal. Okay, now let's see this one. Again, we have the same graph, but this time as x approaches to 3. So we are to determine whether the limit of this function exists or does not exist. If it exists, then what is the value of that limit? Okay, so again, this time this is our reference value, x equal to 3. This is the value that x approaches to. So from the left towards this value, and from the right towards this value, which is equal to 3. Okay, so again, let us determine the limit of the function as x approaches to 3 from the left. Okay, so from the left. So this indicates from the left. So what is the value of the function or the limit of the function from as x approaches to 3 from the left? Okay, so we have to trace the graph. Okay, so tracing the graph going towards 3, so it disappears and it jump up here, then goes again here. Okay, they disappear. Okay, and then you move forward in this graph. Okay, so up to this point. So you see, so the graph from the left going to 3, so it stops here. So this is the limit. So what is this value? Okay, so this value here is equal to this one, right? So that is equal to 2. Okay, so the limit of the function as x approaches to 3 from the left, that is equal to 2. Alright, so this value here. Now, for the other side, the limit of the function as x approaches to 3 from the right. Okay, so we're tracing the graph from the right going to 3. So from here, you go this. So our x values is decreasing, but our f of x is increasing, and it reaches at this point. So at this point, so what is the value of our L? What is the limit of the function using this graph? So that is also equal to, right? So because there is a match between the two limits, one-sided limit or limits, so because the left and the right hand limits match, then we can say that the limit exists, and that is equivalent to 2. Okay? Now, if you are asked to solve for the value of the function, so the value of the function when x equal to 3 is equal to 2. Okay? So there are times that the limit of the function and the value of the function, the limit of the function as x approaches to some value is also equal to the value of the function. Okay? Alright? So I hope everything is clear. Now, if you're asked to evaluate, so you just plug in and then determine what is the value of the function. So I will leave that to you for your practice. So this time we'll go to the infinite limits. But before we go to this part, I just would like to end this video to make it not very long. Okay, so thank you once again for listening. We'll continue on our next video. Alright, so good day once again to everyone, and have a safe and healthy, and please be safe and healthy always. God bless and bye for everyone.